session, we have seen that the different default, private, and static methods inside an interface. So I have seen only the introductory part for the types of interfaces. There are two types of interfaces, functional interfaces, and second one is marker and tagged interfaces. So what is functional interface? So basically functional interface is nothing but a interface which contains only one abstract method. Okay, it is introduced in JDK 8 version, and there are few inbuilt functional interfaces, for example, runnable interface, action listener interface, comparable interfaces. These are all examples of functional interfaces, which are inbuilt functional interfaces. And if you need to create any functional interface, then you can create with this syntax, interface name, which has a single abstract method, and with the annotation functional interface. Okay, so this annotation is not compulsory. You can skip this also if you want, but if you want, you can give it. And whenever you are creating any functional interface, that doesn't mean that it will never have other methods. It will always have other methods, that is concrete methods, which is nothing but default methods. You can write n number of default methods. You can write n number of static methods, private methods inside an interface. It is also known as SAM interfaces because single abstract method interfaces. We can annotate with functional interface at the rate functional interface. This is example. So Java 8 has defined the java.util function package containing lots of functional interfaces. Some of the functional interfaces defined in Java 8 are predicate, consumer, supplier, function, etc. So we are going to see the predicate and consumer interface in detail. So first we will create one functional interface. In module 11, I am creating the package functional interface. Module 11 dot functional interface. Inside this, I am creating new interface. Okay. Suppose that interface's name is, I am giving as functional interface itself. Okay, name I am giving same. Finish. This interface is, I want to make this as functional interface. So you can add a notation, functional interface, and you can create any abstract method. Suppose the abstract method is public integer add method, which takes two parameters, integer and integer. A and integer B. This is function interface. This may have n number of static default methods. So you can create default method. This stated out.println. So you can add n number of static methods, private methods, default methods inside an interface, but only one abstract method. That is why it is also known as single abstract method or SAM interfaces, single abstract method interfaces. Okay, so this is nothing but the interface, and you can implement it in any way using the anonymous inner class or using another separate class, or we can use lambda expression also, that we will see here. So I'm creating example to show the use of lambda expression, including main method as well. Lambda expressions are mostly used for providing implementation to the functional interfaces, because functional interface has a single abstract method. That is why it is mostly used to provide the implementation to interface which has functional interface, nothing but functional interface. So what is Lambda expression? So it is a short block of code which takes in parameters and returns a value. Lambda expressions are similar to methods, but they do not need a name and they can be implemented right in the body of the method. So syntax of the Lambda expression is nothing but the brackets. It always starts with the brackets. Inside it, you can give parameters if you want, if you have any parameters to that method. Then the arrow operator, we use this for defining Lambda expression. This is important. Then the expression or parameters and the statements which you want to give. Okay. So it is important feature of JDK 8 and useful for following purposes: fewer lines of code and sequential and parallel execution support by passing behavior in methods, rather than creating a separate class to provide the implementation to a single method. You can use anonymous inner class and Lambda expression. Now we have already seen the use of anonymous inner class. So we will create this functional interface reference, and after new keyword you can give functional interface, and this is the add method. You can provide the implementation to this, right? So here I am simply adding a plus b. This is the code. This is nothing but we have created through or provided implementation to add method using anonymous inner class. Now, in a similar manner, you can provide the implementation to this implementation to this add method of a functional interface using Lambda expression. Lambda expressions are used to provide implementation to the functional interface only because it has a single method, and using the Lambda expression, it will immediately identify that which method's implementation you are providing. If your interface has multiple methods, then it will never use Lambda expression, because the compiler will never understand for which method you are providing implementation. Okay, that is why we are using Lambda expression. So here I'm calling this add method by passing some value, if and 96. This method returns the value. So I'm using directly system.out.println statement. Addition is equal to state. Now we will see how to create the Lambda expressions rather than using this anonymous inner class for implementing the methods. Okay. So firstly, lambdas are introduced in Lisp language. Okay. Maybe you heard about it. Lisp is the language where it is introduced, Lambda expressions. This is nothing but the functional programming. Okay, whenever we are using Lambda expression, that is nothing but the functional programming. So main objective of using Lambda expressions is to enable functional programming, to write more readable code, maintainable and concise code, small piece of code, and easy and effective way to provide the implementation to these methods. So lambdas are just anonymous functions. Lambdas are nothing but anonymous functions. Anonymous functions. That means we are not giving any, or we are not specifying any name to this particular function, and it is a nameless function basically. Okay, it is a nameless function. Lambda is also called closure. Main properties of lambdas is nothing but no name, then no modifier. You don't have to specify any modifier, and no return type to be mentioned. Okay. If that method is returning something, you can write a return statement like this, but you don't have to mention any return type. So basically we are not providing this add method name, We are not providing any access specifier, that is modifier, and we are not providing this. So we are simply using this statement basically to provide implementation to the method. So here, how to provide? I'm copying the same implementation from above, pasting here, and we are changing it to lambda expression. So this functional interface takes two parameter. This add method takes two parameter of integer type. Okay, we don't have to mention the type of variables also or parameters also. Instead of that, you can simply use this arrow operator and the block of code. At the end, you should give semicolon. So this is nothing but we are writing a code for, 1 second, I have written the code outside of main method. And this should be saved in one reference. That reference should be of functional interface reference. Okay, so I'm using this same. Instead of this, I'm using the name enter 1. So what we have done, we have simply copied this implementation. We have removed these 3 parts. We have kept these 2 parts only without data type, and I'm using the return statement as it is. Okay, so if your now this is a single method. This is a separate method which is returning one value. If you have to return something, then you must give this brackets. Okay, you must give these brackets to provide write the return statement, and you can call using this reference interrupt1 dot add, and same statement I will write down here. Only I will change the reference to interrupt1 and the values also. Okay. I will execute this. So you can see we are getting the addition 1375 using lambda. Okay, simple implementation, small piece of code. You don't have to write everything like this. You just have to write one statement, right, like this. Okay, small piece of code, block of code we are writing. So this is with the return statement. If your interface doesn't have any return statement, okay, then okay. So this vehicle interface, which has start vehicle, one abstract method, and these 2 default methods, that means this vehicle interface is also what? Functional interface. So I am going to provide the implementation to this start vehicle interface method, vehicle interface method using lambda expression here. So what we will do, we need to create the reference of vehicle interface. Then let me check first whether it is accessible. It is not accessible because it is written inside interface methods. Okay. We'll create one interface here, 1 to 2 interfaces in this example itself. Interface, suppose the same vehicle interface, which has one method, void start vehicle. Okay, this is with the void return type and without parameters. If you want to provide the implementation to this method using lambda expression, we have to create the reference of that interface, functional interface. Then this particular method is not taking any input, or there is no parameters, right? So that's why only empty brackets we are using. Then the arrow operator. Now, whatever the statements you are going to write inside this method's implementation, you can write it inside the block of code, that is curly braces. And here I am writing system.out.println starting vehicle. Okay, starting vehicle. Now this reference, using this reference, you can call a method that is start vehicle method because it has a single abstract method and compiler will able to understand that this implementation is for that method only. Okay. So if that is why we say that we use Lambda expressions only for the functional interfaces. Now you in this implementation, you have used only a single statement of line of statement. Okay. That means you are not providing multiple lines of code here while implementing. Then you can skip giving the block of code, that means the curly braces. Instead of that, you can remove the curly braces and keep a single line as it is as a implementation for this particular method start vehicle. Okay. So this is also one way. If your implementation has a single line of code, then you can skip the braces and give only statement like this. Okay. If your implementation has written data, that means compulsorily you have to give the block of code. Though you have a single statement, you have to give the block of code that is nothing but curly braces compulsorily. Okay. And you can write return statement with this. Okay. So this is how you can provide the parameters. Not compulsory, the parameters should be same. So I have used this parameter here that is with the same name, but you can change it to other values also. Like I am giving N1, N2, and here also I will change it to N1 plus N2. Okay, so in this way you can change the values also. Not compulsorily you should give the same values. You can change it according to your need, and then you can provide the implementation using Lambda expression in this way. So I have explained how can you provide the implementation without parameters with void return type. Then if that method has parameters and a return type, we will see one more interface with only void return type, but with parameter. Suppose the interface name is square and it has one method that is void is the return type, and I am calculating square of one parameter that is n. Okay. Now this method is taking only parameter n as a one parameter, but it is not returning anything. It has a void return type. Okay. So if you want to provide implementation to this square interface, we will use the reference of that. Then it has a single parameter. That's why you have to pass the parameter here. Whatever the parameter name is, you can give it. And it is going to return the value. It is not going to return a value. And only a single statement I want to write here. That is system.out.println square of whatever the number I am getting as input is equals to same. I will calculate a square here using I into I. Okay. So here we are calculating the square in this way, and you can call the method s.square. It is not going to return anything. You just need to pass the parameter. Okay. So we have seen if method is has a return type and parameter also. We have seen how to use the Lambda expression or how to write a Lambda expression if the method doesn't have any return type and parameter. If also we have seen one example of implementation using Lambda expression where the interface method has a single parameter, but it is not returning any value. Okay, so basically we have seen all the types of methods here and how to provide implementation to this functional interfaces method using Lambda expression. Clear? Understood? Any doubt?
Can you please show me that functional interface in module 11? What you have declared there?
1 second.
Because here simply we are creating the object and then we are writing the function. I think we have just written a function signature of add.
This one.
Default. Okay, add function signature. Yes. So for this int A and int B, we are providing it. Okay.
Yes. Because when we say that it is a function interface, then we have only a single abstract method inside that
Yes.
interface. But you can write n number of default default private static methods inside an functional interface.
Correct. But it should have at least one abstract method.
Yes, it must have at least one abstract method.
Okay.
So as we have seen, the examples like Runnable interface. The Runnable interface is functional interface. It has a single abstract method that is run method. And this Runnable interface is basically used in threads for running or execution of thread. Okay. Then another one is we are going to see the next ones like other implementations like consumer interface and predicate interface in this. Okay, directly. So till here, any doubt?
You can just scroll down a little bit down.
Okay.
Yeah, just 1 minute.
So whenever you are writing Lambda expression, you should use the functional interfaces reference.
Yes.
And then provide the implementation using this arrow operator.
Yeah, actually here, where you have kept the cursor, we have given functional interface 1 is equal to AB and return A plus B. So in the system.out.println, why we are calling interface 1.add? Because add, nowhere it is mentioned.
Yes, that is the reason, that's the part of the functional interface and using Lambda expression. Because what I said, we are not providing any name. We don't have to provide any modifier. And we are not providing any return type to this method implementation. What I have done, I have implemented this method using anonymous inner class here. If you are providing implementation in normal way, using class which implements this functional interface or using anonymous inner class, how will we provide? In this way, where we have to mention the public as access modifier, return type as integer, name of it as add, and then the parameters with the return type or data type, right? And then we have to provide the implementation, actual implementation of that method, right? But when you are using the Lambda expression, you can skip these three parts because what I said, there should be no name, there should be no modifier, and there should be no return type. That means you are skipping these three parts. I have directly copied everything from here. Okay. From integer A, integer B, and this block of code. Okay. I have copied.
As we have already written the function body here.
Yeah.
So no need to no need to write the function body again. So directly we can call interface one.add with a
not like that. If I am removing this, no problem.
Okay.
You can provide the implementation using Lambda in this way only. I was just explaining that if we are providing the implementation in a normal way, you can provide in this way, right? But in Lambda expression, you can skip all these three parts. You can directly copy any or write from here and remove the data types of the parameters also. Okay, I will explain one more time. So this is a square method. Okay, if I am providing implementation to the square method using anonymous inner class, then I can write the SQ as the reference, right? Then using anonymous inner class, I will provide the implementation to this particular method, that is square method. Okay, add an implemented method. Now this is a square method. If we are providing implementation using anonymous inner class or normal class, which is implementing the square interface, okay, then how will you provide? You have to write a complete signature of a method, that is public void square as the name, and it takes one parameter, right? So here what I am doing, I am writing one statement just to show the square of n variable is equals to, I am calculating square here using n into n. Okay, this is my actual implementation for the square method. Okay, now I want to call this particular method. How we are calling? We are using this reference itself because we have written this inside using anonymous inner class. That's why we have to use this reference itself to call this implementation, right? So how will we call? We are calling sq.square. And passing one value to it, right? But if we are providing implementation using lambda expression, you can skip this 3 part. You can simply use the brackets. Inside that bracket, it is taking only a single parameter, right? So whatever the parameter name you want to give, you can give. It is nothing but the variable name itself. Then the arrow operator. I am providing a single statement of code here as a implementation. That's why you can write directly that statement, a single statement. You don't have to write this block of code. Okay, that means you don't have to give these curly braces. But if you has multiple statements, then you have to give brackets. Like suppose here I'm creating another reference S1. I'm changing the variable name also. And here I want to give multiple statements. So suppose here you can declare variable also. So I am declaring a variable integer sq is equals to, I'm calculating the square here using math.pow POW function. Okay, that takes double parameters. We have integer parameter. So we will directly calculate j variable into j variable, calculating square and adding that square variable here. At the end, semicolon. Okay. Yes. Declared variable. Okay. Here you cannot declare the variable. Okay, lambda expression where local variable declaration is not possible. So instead of that, you can declare in a main method and you can use it. Initialized it to 0. Duplicate local variable because I have already used it. Change the name here also. Final must be final. Final, why it is not taking? Okay. Duplicate variable था इसकी वजह से नहीं हो रहा था. Now it is defined. We have defined this local variable. You can write any code. Okay, but I have written 2 lines of code inside the method implementation. That's why I have to give these brackets. Okay, if you are writing a single statement, then you don't have to give the brackets. You can skip that part also. So it is, we are simply reducing our code to a smaller piece of code. Understood? So as this is a functional interface, square is a functional interface. It has a single abstract method which don't have any, or which doesn't have any body. Whenever you are writing any lambda expression, compiler will automatically understand that this implementation, as it matches with the single parameter, that means you're passing a single parameter. That means this implementation is for the method square, which is written inside this functional interface. That's why we don't have to give a name to this particular method, a nameless function or anonymous function. Understood?
Yes. Yes.
So it is not that we have already provided the implementation, that's why we are skipping it. No, we can give the implementation in this way also using anonymous inner class or normal class which implements that interface, and using lambda expression also. Okay, so if you are providing lambda expression, then you can directly
Yeah.
skip these three parts. You can only give the parameter part, those also without data type, and
Okay.
you can write a block of code, whichever as an implementation. This is only possible for the functional interface because functional interface has only a single abstract method. That's why compiler will automatically understand that this implementation, whatever you are providing, is for that particular method only. Okay, clear?
Yes. So a lambda expression can have parameters, or without parameters also I can write it. And with respect to functional interface, at least one abstract method should be there that we have to define. And again, with the object of that particular functional interface only, we are supposed to write the lambda expression. Or if you have written the function, we can directly call it.
Yes.
Okay.
So basically, this is not an object. Don't call it object. Okay, we are
Okay. Okay.
not
Square.
creating object. It is
Fine.
just a reference of the interface because we cannot
Yes,
instantiate the interface.
we cannot create the object of the interface.
Yes.
Yes.
So these are all references.
References. Okay.
Whatever the functional interface method implementation you want to give, you just need to create the reference of that and then provide the implementation using that particular lambda expression or anonymous inner class, anything. To call it, we will use the same reference and call that particular method. Okay. Shall we go ahead? Understood, right?
Yes, yes.
Okay. Now, as I said, there are built-in functional interfaces. So first interface is predicate interface. So predicate interface is a functional interface and it is defined in function java.util.function package. We will see that it is a function that accepts a single value or argument and does some sort of processing on it and returns a Boolean value, true or false value as an answer. Okay. The predicate functional interface can also be implemented using a class or using lambda or lambda expressions or anonymous inner class also. So there are some extensions to this predicate interface, that is int predicate, double predicate, long predicate. It is basically depend upon the data type only. Right? These are primitive data types. So above predicate functional interfaces accepts only primitive data types or values as arguments. That means if you are using int predicate, it will only take the integer parameter as a input. If you are using double predicate, then it will only use double parameter. Okay. It will always return the Boolean value, but the type of parameter it is going to take, it is depend upon this type of or extensions of this predicate interfaces you can use. You can normal predicate interface, we can pass any type of data as a parameter. So example is this predicate interface with T as a T is nothing but the generic type. Okay, it is defined with the generic type. This is the interfaces. This is already built-in interface basically. It is already written or provided to you. Interface predicate with the T as a type, generic type. You can pass any type of data here. And it has a single abstract method that is Boolean test, which is parameter that is defined using T. It is known as diamond operator. Okay, this is nothing but a diamond operator where you can provide any type of data. This is a generic type. Okay, for all the types, we can write T. Type T. Sorry, I got disconnected due to network issue. Okay, what I was explaining is predicate interface. So here, predicate interface, you can provide the implementation using like this, using a class, anonymous in a class, or using lambda expression also. When you want to give the implementation using lambda expression, then you must use the predicate interface reference. Then the lambda expression, as it takes only a single parameter, whatever the parameter you want to give, you can give it here, arrow operator, and this particular condition which returns some boolean value, whatever you want to give, you can give. So when to use a predicate interface? Predicate interface is mostly used for writing a code where you want to check something, and this method should return boolean value. Okay, so you can write anything, whatever you want, you can use that for writing. It is already provided code. So here I am creating inside the functional interface itself, I am creating one more package, that is an inner package named predicate. And we'll see one example. Creating one class, predicate interface example, including main method. First, we will see the predicate interface. The predicate interface, you can see this is the annotation functional interface which you can give. It has a single abstract method, that is Boolean test. It takes a single parameter and it returns Boolean value. It has default methods also, static methods also already written. This is introduced in JDK 8 and it represents a predicate of one argument, okay, Boolean value. And it is defined in the java.util function, okay, java.util.function package. Now we will create one age validation program, which is nothing but used for validating okay, we will do age validation program itself. So we will write here directly. Interface example, I will write here age validation example using predicate. Now I want to make this class should implement the predicate interface. So I'm using implements keyword and I am using predicate interface here to be implemented. The type of parameter which we are going to pass, that should be mentioned here. That's why it is taking it. Add unimplemented method. And whatever the type of argument you want to pass, whatever the type it is going to take as a parameter, that you should mention here. Okay, we never keep t as it is. We have to give the data type. So we are going to do the age validation program. So age is always in the integer format. So here I am, we will pass, we cannot pass int here. Okay, we never pass in our diamond operator, we never pass primitive data types. You have to use the wrapper classes, that is integer. Understand this concept of diamond operator, because in collections also we most use these diamond operators. That time you should not get confused. Okay, so compulsory understand this. So whenever we are passing or using the diamond operator, you should use wrapper classes as a type. As we are going to do the program for age validation, integer is the type, data type I am passing here as a parameter. Now we will pass or we will provide implementation to this test method. So what is exactly the test method will do? I want to check whether the age value, that is whatever the integer value I am getting as a parameter, that should be greater than 18. Okay, so basic functionality we will do, like if this I value, or instead of this I will change the variable to age. If this age value is greater than 18, greater than equal to 18, then I will return true. Okay. Else I want to return false. Else I want to return false. So basic functionality we are doing using this predicate test interface. Implementation is provided. Now you can create the reference and test it. So here first, now this method becomes instance method. That's why we have to create the object of this class. Predicate interface P is equals to new predicate interface example. Now we will call P dot. Okay, now this method returns a Boolean value, right? So we will use system.out.println statements, validating age using test of predicate interface. Okay. This I have mentioned so that you will understand. Now after this, I am checking age.test, passing the values 10. Okay. We will call output will be there. We will get it here. So we can use this P dot. The method is test, and to the test method, I am passing the integer value 10. Okay. Same like this, I am passing other values. 5 values, we will test for 5 values. 63 minus 41, 74, or 18 itself, and checking for 12. Okay, values I'm changing to 63. Minus values also, what we will get output that we will see. If we are passing exact 18 value, then what we will get as output from this test method, that we will see. Okay, so you can see for 10, we are getting false because it is not greater than or equal to 18. So we are getting false. 63 is greater than or equal to 18. We are getting true as the output. For minus 41, it is getting false. For 18, we have used equal to. That's why we are getting it as true. And for 12, we are getting false. Okay. So basically, this is used for testing purpose. Now, same thing you can use for you can write the lambda expression also. Instead of providing implementation in this way, you can write the lambda expression. I will show you the use of lambda expression here for the same. That time you need to use predicate interface reference, then the brackets. The brackets takes one parameter. So I'm using the same parameter name. You can use different also. Then the arrow operator, and then the statements. Now we have a block of code. So we have seen the conditional operator also, right? So here you can use the conditional operator, like age is greater than equal to 18, question mark, you can use true, colon, false. You know the conditional operator, right? So here you can use the conditional operator. And sorry, we have to write the return statements. So that's why we have to give the brackets, because we want to return the values. Return true and return false. It's not taking. Label expected. It is not taking for this. Okay, no problem. You can use if statement then instead of conditional operator. Semicolon. I am writing. Write in this way. Age is greater than or equal to 18. Written true. Else written false. This is not necessary. Semicolon should be there. Greater than or equal to is undefined. Yeah. Int. It is taking as an object. That's why it is not going to take. Okay. By default, the predicate interface considers that we are passing object. Okay. That's why it is not taking this. So you can use directly.
But usually in the lambda expressions, we are not declaring any variables, right? Which are there inside the bracket. Directly we can take it.
Yes, this is a parameter. Like here we have passed this parameter when we have used it. Same thing we are doing here.
Okay.
But by default, it is considered as, because we have, there is no mentioned data type, right?
Correct. Capital T.
It's considering it as an object. And that's why on object, we cannot use this direct.
Greater than, yes.
That's why it is giving us an error that this operator is undefined for object and integer. Okay, so that time you can convert it into integer, like using integer dot %. But actually this is also not string. It is object. So we have to use integer dot value of. I have also never written this particular. It is not string. This is for string purpose. Okay, no problem. So most of the time you want as a object as a parameter, you can use this lambda expression, or normal thing you can use in this way. Using anonymous in a class, you can specify the type. That's why it will get easier to understand and it will get easier to perform also. Okay, so you can use direct class implementation or anonymous inner class. I will check for this. Still, how can we change it? Because it takes as an object. So that's why it is not considering the integer. We can do casting also. We will try doing casting. Yes, now it is working. Okay. So we are basically casting this age from object to integer, and then we are checking it with this. Okay. So this is a lambda expression. You can call using this p1 dot. The method is test itself. Whatever the value you want to test, you can test it.
Is that age variable should be same like what you have declared in the test?
No.
No, right? Okay.
You can change anything. Anything. You can give any variable name. It is just a variable name. But make sure that whatever variable name you are taking as a parameter, that should get used here for testing purpose. Okay. So this should be same, but not compulsory, it should be same. So basically it is not mentioning any variable name. It has only T as a type and T as a variable name mentioned. So it is up to you. Which what type of variable you, or whatever the name you want to give, you can give it that way.
Is that capital T name is fixed, or can I take some other character? U, P, O, K?
No, it is fixed. It is predefined. So T actually specifies the type of all type. Okay, it is nothing but a generic type. So whenever you want to create any generic type of interface, generic type of class, you need to mention this, or you need to write this diamond operator and mention this T. Okay, so it is for generic type. So any type of data you can pass to this predicate interface, any type of parameter you can pass to this particular test method. Okay, all type of data types. We are not, when you are creating any method, so here we have created the square method with the integer type of parameter. So it is only work for integer type of parameter. But this predicate is for generic. Generic means all type of data type you can pass. Only thing is when we are using the diamond operators, you cannot pass the primitive data types. You compulsory have to pass the wrapper classes. Okay, clear? Understood? Predicate interface,
Yes.
any doubt? Okay, so here we have created the predicate interface. We have provided the implementation to test method using the lambda expression. So this you can skip, you can change now because the error was for casting. Now it is already casted. You can change it with the conditional operator by removing the this brackets. Okay, conditional operator, you can use the conditional operator also. This is one parameter, one type of interface. Second one is there is a by predicate also. By predicate is used to take it is extension to the predicate interface, which is function interface. Instead of one parameter, it takes two parameters of different types. Okay, so instead of one, it takes two parameters, two arguments, and it does some processing and returns a Boolean value. It is the same. By means two. That means if you want to do some testing on two different parameters, you can use this by predicate interface instead of predicate interface. Okay, predicate interface has single abstract method with a single parameter. By predicate interface has one abstract method itself. It is also functional interface with two parameters. Okay, it will also do the same thing, testing, and it also returns Boolean value only. Then these int predicate, double predicate, long predicate, it is basically used for particularly those type of data types only. Okay, if you want to see, I will show you this particular predicate interface, int predicate. So this is a functional interface which is taking integer value. Okay, so if you want to provide the integer value, then you can go for this int predicate. Same for the long and double predicate. Okay, now instead of this, if you want to use by predicate, then it takes two parameters. So now you can see there we cannot use it is not using two t's. Instead of that, it is using u. It is universally defined, t and u. Okay, so this t and u, different types of parameters you can pass and perform the same testing part and returns the Boolean value. Clear? So these are extension to this particular interface. Extension means these are not extended interfaces. Okay, these are not extended interfaces. You can see here, it is not mentioned that it is an extended interface. Okay, but it is extension means functionality is extended according to our need. Functionality is extended for the predicate interface. Clear? Okay. Okay, then we will end our session for today here. We will continue with the next consumer interface part in the next session. Okay, thank you, everyone.
Yeah, thank you.